Hello, Calc 2 students. This is a short video to help you with question 7 of section 7.7 homework. Essentially what I'm wanting to show you is that you can use your TI-84 calculator to get the exact value for the area under a curve, at least as far as you can assume perfect can be. So the question that we're going to deal with, and I'll set it up right now so you can see the one I'm using. Yours may look slightly differently because WebAssign has the habit of changing. I think in this case it'll be the top number. So your question might say 13, 10, 2 or something. But apart from that, it's the same. So you try to find the area under this curve here. 26 over root x between 1 and 4. If you sketched it, starting at 1 and 2, 3, 4 and finishing at 4. It's an unremarkable curve, it just kind of looks like that. So you're trying to find, or you're going to need to know the exact area under that curve. And so let me show you how you can get that, and then why that's important to answering this question here, which is essentially what's the error in the trapezium rule, what's the error in measurement from the midpoint rule, what's the error in measurement using Simpson's rule. So I'm going to stop share. Going to set up my TIA. Okay. And we're ready to go then. So if you have a TI-84, you should be able to do a very similar thing. So the first thing I want you to do is type y equals, and then put in whatever happens to be the equation. In our case, it's 26 divided by the square root of x. And that's that part done. So y equals, put in the equation. Then you hit window, and our integral starts at 1 and finishes at 4. So x min will be 1, x max will be 4. Then you move on to the next one and you press zoom. And the one that you're going to use here, if you scroll down to 0, is called zoom fit. So 0, zoom fit, press enter. Excuse me. Now what that does is it essentially draws a curve in the window that uses the most amount of information. And now you proceed to essentially the final step. In blue here, you'll see calc. So what you would do there is you tip the second button, calc. And the one that you want from this list is number 7. So choose 7 by hitting 7 on the keypad, or just go there and press enter. Now it's going to ask you 2 questions. The first thing is lower limit, which was 1. Enter. Then it's going to ask you for the upper limit, which was 4. And when I press enter, it's going to do a little fill in just to show you what it's up to. And then it will tell you the exact value for the area under this curve. And that answer is in blue, and it's 52. And that's how you use your calculator to do that. So now let's return to our question and see how that is going to allow us to finish off this guy here. So we now know the exact area. So what does ET mean? Well, the only one I've set up is this one here. If you use the trapezium rule and you use 6 strips and you do it on this function here, then the answer you will get is 52.233111. That's 6 decimal places. The guy that they call ET is the error that you get in using, what would this be, T6. And the one here would be the error that you would get if you used T12. The error if you used the midpoint with 6 strips or 12 strips. The error that you would get when you use Simpson's rule for 6 strips here, and you put the error there. So how do you get this ET? It's made up from a simple calculation. You take the exact value. And you subtract what your estimate was. Now, in this case, the exact value is 52. Take away your estimate, which is 52.23311. Now, that will leave you with a, let's see, 0.23311. And in this particular case, if I'm not mistaken, it's negative. And it's okay. Answers are allowed to be negative. It's really basically saying your estimate is bigger than the true value. And that will, in many cases, happen. So negative 0.23311. Now, if you wanted to get the answer that goes here, you would take this answer, right? And you'd go 52, take away this answer here. And you'd get probably a negative answer again. But sometimes you'll get a positive answer. Now I'm going to make this up because I know it's not true. But let's just suppose that if I did Simpson's rule 16, that the answer I got was 49.999912. If I then did the exact value 52, take away that guy, I would find out my error, which is essentially how far away from the real value this guy is, would be a positive number, 0.12340 zeros and an 88. And it's essentially all you need to do. Now, it finishes off by asking you things, well, do you notice what happens if you double the number of strips? By what factor do you increase or decrease the error? Well, it shouldn't surprise you that when you do 12 strips, the answer is more accurate. So the error gets smaller. So you'll be able to find out, is the error half the size or a quarter of the size or whatever it might be. And you do the same. Once you know these two values, you can find these two errors. And once you know these two values, you can find these two errors. And you should find that doubling the number of strips will increase the accuracy. And by what factor? Well, it's a little bit interesting. You might have thought that if you doubled the number of strips, you would double your accuracy, right? But actually, it's better than that. If you double the number of strips, the accuracy or the error decreases by a factor of 4. So in other words, the error will be 1/4 what it would be at 6 strips if you use 12. The error would be 1/4 if you use 10 strips instead of 20, right? It's a noticeable and significant decrease in value. Now, when you do Simpson's rule, and you do it with 6 strips and then it's 12 strips, the factor by which the error decreases is even better than 4 times. But I'll not tell you that number, I'll let you do it. But it's an easy thing to do. Don't you take one error and divide it by the other, smaller on top, bigger on the bottom. If you want to reverse it, that's fine. That probably makes more sense to do the bigger over the smaller. And roughly the answer will be about 8. Don't worry if it's 7.9 or 8.2, you'd call that 8. Or maybe it's 12, maybe it's 80. whatever that number might be, make it nice and round. That will be the decrease by a factor of when you use the Simpsons rule. So I hope this video will be of some help for you, and I look forward to seeing you all on Monday, guys. Bye for now.